Okay, AP Statistics, here we go, Section 2.2, Day 1. We're going to be talking about a normal curve today, and that's something that we use over and over throughout the entire course. In the first place, something called a density curve. I think that's the first time you probably ever heard that term, is any curve with the following properties. It's always on or above the x-axis, never below, and the area between the x-axis and the curve is always exactly 1, which if it's like, think of a curve above a histogram where it's a relative frequency histogram. So maybe this is 0.2 and this is 0.3 and that's 0.2. How many do I have there? 3, 4, 5, 6, 7, 8, 9, and 10. So there's 100% right there. 20, 30, 20, 10, 10, and 10. Well, if you put a curve over the top of these, the area underneath that curve would have to be 1 because those decimals add all up to 1. So that's the idea there. Now, example, if you randomly pick any real number, real numbers include fractions and decimals and irrationals, between 0 and 1, possible outcomes can be described with a uniform distribution as follows. Look, I would go from 0 to 1. Here I'll put a 2 just so you see what I'm doing on the number line. And then since they're all equally likely, if I'm randomly picking one, we won't have a peak. We'll just have, one really wide peak right there. For this to be an area equals 1, to represent all 100% of the possibilities between 0 and 1, this height would have to be a height of 1. Okay. Draw a uniform density curve for each of the following possibilities. If I randomly pick a real number between 0 and 4, 1, 2, 3, 4. So this would not be as tall as this one, because to have the area equal 1, length times width has to equal 1. If this length is 4, this width has to be 1/4, has to be a fraction. Between 2 and 6, well, that's going to be the exact same thing. Exact same height. For the area to be 1, this would have to be 1/4 because 6 minus 2 is 4. And 4, this 4 times this 1/4 will give me the area of 1. That's the area of a rectangle, length times width. Now between 0 and 10, I'm not even going to try and put all those. I'm going to make it look like I did, but I probably didn't. I would make a uniform distribution. Now the height of this one would only be 1/10. Okay, learn this and then ignore it. I think we talked about this in class once already. The mean, this could be a multiple choice question at best. That's the only time you would ever see this. The mean of a density curve would be a point on the x-axis where the density curve would balance if it were made of solid material. And the median, as a measure of center, is the point on the x-axis where if you drew a vertical line where the median is, it would create equal areas for the curve. So since this is symmetric, if I drew a line right there, it would do both things. I would have the same area on both sides, and it's the point at which it would balance if it was made out of some kind of solid material. In symmetric distributions, the mean and the median are the same place. Okay, go to page 2.